right, so we'll get started. So today we'll be talking about the OCI Resource Manager for base database service and exadata-database-service deployments, and how you can discover, automate, and standardize your base database service and exadata-database service deployments. Now, my name is Sheena Agarwal. I am a product manager for database cloud services here at Oracle, and I'm joined by my colleague, Leo Alvarado, who's also a product manager on my team. Hi, Leo.
Hi, Sheena. Hi, everyone. Thanks for joining our Tech Talk session.
Thanks for joining. So just a safe harbor statement for all of you. Make sure you don't sue us. And yeah, so we already had part 1 of this tech talk early in March, where so here's the QR code and the link if you want to scan and check that out. I'm going to remove this to the side. And yeah, so in this previous tech talk, we spoke about how to use the OCI Resource Manager stacks to discover the Exadata database service resources and use the generated Terraform stacks to provision your database service resources in other environments for your service. So just to continue on that, today we'll be continuing on that to be able to discover the same resources, how to discover the resources for base database service and Exadata database service on exascale infrastructure using ORM. We'll go through some examples, some use cases, and see how to create your own custom stacks for your organization, right? And then we'll also have a Q&A section at the end if you have any questions. So why do we have so just like we looked at before, right? Why do we have the OCI Resource Manager? We can manage, we can plan, apply, or destroy our Terraform execution in a dedicated manner. We can manage the state and prevent any conflicting updates, reduce any drift across the teams. We can also use it for audits and visibility, just to make sure we have the logs and everything for whatever we are doing. And of course, we can automate our deployments using CI/CD. So for the OCI Resource Manager, we have a stack, which is the exact Terraform configuration that we'll be using to provision and manage our OCI resources. So once we have the stack, we can create a job, which is created when we run a Terraform action on the stack. This action is usually plan, provision, or destroy the resources that we have specified in our Terraform configuration. We have a template, which is the pre-built configuration blueprint that we use to specify what resources we want in our OCI resource stack. So that's that. And yes, we can sync it with any configuration source provider like Git for our CI/CD configurations. Then compartment basically just specifies that we have all these resources in our compartment. And yeah, so let's start with how you can create a resource stack from your specific compartment. So let's look at a live demo of this. So this is my OCI console, which I've already logged into. Now, if you go to stacks in the resource manager, and if we create a stack and we choose an existing compartment, whichever compartment we want to check the resources in. So here I have already created my resources in this compartment, which I'm going to use. Let's pick another region, right? And then I want to be able to select which services I want it for. So for right now, I just want it for my database services. I can specify the name, whatever I want, and simply click on next and create, right? So this creates a stack. It gives me all the database resources that I have in that specific compartment for that specific resource. So just to give you an example, I've already created this stack. I can go ahead now. I can use this created stack to discover my resources. So I can go ahead and download this Terraform configuration. I can go ahead and unzip this Terraform configuration that I've downloaded. So here I've already unzipped it for you. And we can see that it gives me my database.terraform file. So this is what my database.terraform looks like, right? It has all the components, all the OCI resources, all the OCI database resources that are present in the specific compartment that I chose. So here you can see it gave me all the base database resources. So let's say, let's see this one. So this is one of my base database resources, right? Let's say if I go back to my compartment and I check the base database service, okay, I'm in another compartment, right? So make sure you're in the right compartment. So once you choose the right compartment, you can see that this SSO26AI ASM2 is one of the base databases that I have, right? And this is the one here, SSO26AI ASM2. So it gives me all the information for this specific resource. It gives me the compartment ID, database storage, the DB home inside it, all the details that I need to know. Similarly, it also gives me the Exadata database. So we can use it to discover resources for base database service as well as Exadata database service on exascale infrastructure. So let's say I want to check the resources for Exadata database service on exascale infrastructure, right? So I have this specific VM cluster already defined in my compartment. So if I check here in the downloaded Terraform configuration, I can see this specific resource here. Right? It has all the backup subnet ID, all the all the needed resources that have already been created. So this is part of my resource discovery. Now, once I have already discovered my resources, what do I do with these discovered resources, right? One, I can reuse this configuration to update the Terraform configuration for other environments. So what I mean by that is, let's say I already have this Terraform configuration that we just downloaded. I can go ahead and copy this and create a new one. Let's say this time I want the name to be something else. So I can simply go ahead and change the display name, right? So let's say we change it to test 2 and whatever else I need to change. Let's say I want to have a different shape here. I want to have a different shape attribute. I can change whatever I need to do, and then I can reuse this same Terraform config after updation. I can clone it for different environments, and I can apply this Terraform configuration to provision a completely new environment or multiple environments. Same drill. We go to the stack. So let's say we go to the stacks. So once again, we do the same thing, right? I would create a stack. I would choose my own configuration this time because this time I'm trying to not, so earlier when I was trying to discover, I used an existing compartment to discover the resources that were already created in that compartment. This time when I'm trying to create my own resources or provision new resources, I can go to my own configuration that I have created from my already discovered configuration. I can choose the zip file that I just, uh, you know, downloaded and updated for my use case. I can specify the compartment I want it in and whatever else I need it. And then I can simply click on next. And then now I also have the option to create and run and apply. So if I just want to plan the resources and then decide whether I want to apply them or not, I can do that. But in this case, I'm just going to run and apply. So this is going to create a new um, uh, resource for me. So we'll just uncheck this for now. This was just to show it to you. So I can go ahead and create these resources. So it goes into planning stage. And once that is done, it can go ahead and create those resources, right? So that's how you can discover all of your database resources and also use the same discovered downloaded Terraform configuration file to update and create your own new resource in any of the other environments and apply the same configuration. Yeah. So that's about it. And then now, after we have done all of this, right, we can also do a template-based stack creation. We can create our own templates. We can create custom templates, custom stacks for your own organization. So I'll let my colleague Leo walk you through an example of how you can create your own custom stack to provision your environments the way you want them. So over to you, Leo.
All right. Wait, let me just share. Right. Can you see my screen?
Yes.
Okay. So yep. Thank you, Sheena. So now let's move to the other component of Oracle Resource Manager, in which you can create your own private templates for building custom private stacks. So let me start with asking you this, like how many of you have had this experience, like you provisioned a new database or an application environment, and then a week later, like someone says like, hey Leo, like this isn't behaving the same as our production environment. And then you start digging, and sure enough, you found out like different updates, different patches, different OS configs, and maybe a different version of a middleware component slipped in, or the new database image version, and nobody did anything wrong. It's just drifted. So that's the problem that we're trying to solve today, the environmental drift. And what we actually need is to encode the standards into our infrastructure itself, making a golden configuration, and that's the only configuration that gets deployed to our environment. Okay. All right. So with Oracle Resource Manager, combined with Terraform, so it lets you build custom stacks where your database images and application images could be pre-baked or pre-approved and deployed consistently every single time. So you can use the private templates available in Oracle Resource Manager for stack provisioning and managing your OCI resources. So private templates are Terraform configurations that you can share with others in your tenancy. So for this example, like it's a private template for just provisioning an Exadata database service on dedicated infrastructure. And in this template, you can define specifically a an Exadata infrastructure specific to an environment, or it could be you provision a database on a specific VM cluster, or it could be provisioning pluggable databases on a specific container uh, database. So next slide, please. And then when we create custom application and DB, like a full app and DB, private stack. So we have this different building blocks. So let's talk about the first building blocks, which is the custom database software images. So in OCI, it lets you create a custom database software images. So these are essentially your organization's golden database image. So you can take a base Oracle database version. You can specify a specific RUs for your database. You can specify it with an your approved patch set, and you can even embed your standard configuration, save it, and then you can save it as a reusable artifact in OCI. So custom database images allow you to develop, deploy, and audit database standards, and you're able to incorporate this custom database software images into your automation deployment process by just calling these images from your Terraform scripts. And the so why is this important? So your database team can just define the standard once. So you can define a database image with your approved patch level, required PSUs, or any custom configurations baked in. And that every database that gets provisioned from this image starts from the same baseline. So there are no exceptions and no drift at birth, and that you can also incorporate governance into these images, like your security team, like if they require specific PSU for compliance, so you can also embed it in the image. So you're not relying on someone remembering to apply it. And then when Oracle releases a new patch set and your team certifies it, so you can just simply update the image, version it, and all future deployments automatically pick up the new baseline. And that existing environments can be updated on a controlled schedule. And the same philosophy applies also on the application tier. So as you can see in the slide, so you can also create custom application images in OCI. So whether these are compute images or containerized application layers. So it gives you the same guarantee on the application side. So you can standardize on your middleware configuration, application runtime. You can include all your security agents, monitoring tools. So you can have it all pre-installed, pre-configured, and validated before they ever touch a deployment. So with the custom application images, so you get a consistent runtime that matches what your QA has tested. You can include security and compliance tooling on your custom images, and of course you can have a faster deployments because the image is already pre-built. So you're not installing software at deploy time. So let me just share quickly. I'll just need to share. Okay. All right. So for the custom database software image, so let's say you're going to create a custom database software image for exadata-database-service on dedicated infrastructure. So you just need to go through that. And then on the left panel, so you'll see here software images. So you can create a software image. So you can choose to create a custom database software image, because so you can choose a release database release, and then you can choose the specific release update for that specific database version. You can even have one-off patch numbers or upload an Oracle Home inventory, and then you can just simply click on create. So once you have created your custom database software image, so you can just copy the OCID and then refer that and include it on your Terraform script. So whenever you create a database home, it can use the same custom database software image that you have created based on a specific release unit. So same with the application. So for the application on your OCI compute, so there's an action there to create a custom image out of that instance. So once you have created a custom image from that, for let's say from your application server, so same thing. So you can just refer it to the OCID, and then when you create your stacks, so you can specify that OCIDs of your custom image for your application. So when you provision both your application and DB, it can use the same custom images. So now let's see how we bring it all together. So Sheena, if you can go back to the slide. Okay, and next slide. So here's where Terraform and Oracle Resource Manager tie it all together. Okay, so having golden images is great, but if your deployments are still manual, so even deployments using those images, so you still have a process risk, as someone could have picked up the wrong image version, or someone could skip a configuration step. So with OCI Resource Manager, it gives you already the execution layer, so you can create a stack. Like here's a sample where I create a custom stack that I have combined both my application server and database stack on one customized stack. And it's the same concept that we have shown a while ago. So you can just define your Terraform stack. You can reference your approved custom database software image and custom application image using the OCIDs. And then Resource Manager will take care of the state management, execution logging, and audit trail, and then controlled apply and destroy workflows. And then, of course, integration with the OCI IAM for access control. So once you've created the stack, so that you can just simply run a Terraform plan and apply and deploy that custom application and database private stack. So I'll just quickly show you another demo. Let me just share my screen. Okay, so if you go to the if you go to your OCI console, and then it's under developer services, and then you'll see here the stacks. And in the oops, in the stacks, so you'll see there private templates. So you can create your custom stacks and save it as a template that you can share across in your organization. So here's the sample templates that we have created. So again, showing you the same example of an app and database full stack. So once you click your private template, you can just click on create stack. So this one, it's a full app and database stack, but here you can see for this use case, so we're just referencing the custom image for the application, but for the database, this is just creating another example showing on how you can just create a PDB out of a specific container database. So let's say on your VM clusters, there's one CDB that is running, and I wanted to create my PDB there together with the application. So I can just copy the OCID and then go back to my stacks and then just um, so this will create the PDB inside that container database, and then we'll create an application server out of this uh, application custom instance image. And then, yep, so you just need to supply the password for your PDB, and then click on next, and then click create stack. So you already have a stack for your a full stack for application and database running on exadata-database-service. And then after you create a stack, so you can just perform your Terraform plan and apply. So, and then you can also have another example. You can also create like a template for just provisioning a full Exadata database service stack. So here, this is the template that we have created for provisioning Exadata database service on dedicated infrastructure. So it will just create the whole stack for your ExaDB. So you can just specify the infrastructure model. You can specify the name of your infrastructure, the database servers, and storage servers count. So we're just going with a minimum of 2 by 3. And then you can specify a variable for your automatic maintenance method, whether you want a rolling or non-rolling apply. And then you just need to specify the where you want to create your VM cluster resource. So you just need to give it a name for your VM cluster, select the virtual cloud network where you will create your VM cluster, then specify the subnet for the client and also the subnet for the backup. And then you can just upload the SSH keys and then provide the required database uh, parameters like database name. And then you can also specify in your stacks the release that your user can choose. And then same with the PDB. Okay, so here is the, yeah. So let's say I'm going to choose 26 AI. Then you just need to provide the password. Yep. And then your PDB name should be PDB1. The same thing. And then we go next. And now you have a stack that you can deploy end to end for your Exadata database service using customized template. And you can just run your Terraform plan and apply. So that's how you can create a custom stacks and then save it as a template. So how you will develop that template, like customize a template. So we will be sharing this in the documentation. So there's a documentation. You can even specify your schema documents. So that's so there's a YAML file that you can configure. That's why you see there on my stack, I was able to combine both application and database on just one customized stack, and even choose the specific parameters that I just wanted to include on my Exadata database service stack to be passed as a variable on my Terraform script. Okay, and yeah, with that, I'll hand it over to Sheena. Yeah, I think you're on mute, Sheena.
Thanks for that. Yeah, so that's about it. And if you have any questions related to ORM or anything related to DB Cloud Services, you can ask now, or also, so we're looking at the Q&A tab in the chat just to check if there are any incoming questions. If not, you can also ask us questions on the Slack channel, which is, this is our Slack workspace, exadata-database-service, where you can access the guides for getting started, the how-to demos, all of the previous Tech Talk series, and any blogs that we publish for the database cloud services. You can also join it using this QR code. If you just scan the QR code, you should be able to join our Slack channel. And yeah, if you have any questions, feel free to ask them now.